Hello? Hello, can you hear me? Hello? Hello, Poonam Sharma ji?
Yes, sir. Good afternoon,
Okay.
sir.
Very good afternoon, ma'am. Very good afternoon. Now, heartily welcome in this session, especially this is UG Third Semester Mathematics and Srinivas Rao. There is a faculty of mathematics. And today, already later to last two classes, we have explained the Riemann integrals concept. Okay.
Yes, sir.
Okay,
Yes, sir.
okay. Now, today this is also very important session, and I must explain some important problems and important theorems, especially the for Riemann integrations concept. Okay.
Okay, sir.
Okay. Please stay on the line. Now already 5 minutes to go. Okay.
Yes, sir.
Okay. Now, good afternoon to everybody here. Now, today we must explain how to find the upper Riemann sum and lower Riemann sum, and upper Riemann integral, lower Riemann integral, and according to their problems. Now, first of all, just you have to see on the screen. Just you have to see the screen, please. Now, already shared the screen. One PDF is there. here especially flow?
Yes, sir.
Okay, it's all right. Now, entire all, especially this note is also posted through WhatsApp. Just you have to see and verify. This PDF is also very important in the final examination, especially. Now, another person is also joined. Now, that person is Poonam Sharma and Shekhar. Sheikh Ji. Okay.
Yes, sir.
Okay, fine. Now, just you have to see the problem. This problem is very most important in the as on the start notes, and at the same time, in the fill in the blanks is also there. Now, objective type is also there. Now, just you have to see, just you see on the screen. First of all, if f of x equal to x, please mute is there. Everybody is mute is there. Some disturbance is there. One person, sir, can you speak little louder? Okay, fine. Is it okay? Can you hear me?
Yes.
Can you hear me?
Yes, sir.
Okay. Now, so one is asking here, your voice is very low, sir. So no problem. Actually, just some problem is there. So please, all mute is there, especially. Okay. Now, see the problem. If f of x equal to x on closed interval 0, 1 and given the partition is, now according to the interval, how to deviate the partition points? Just see how to see the interval is there. This interval is closed interval 0, 1. That interval is consisting, one of the element is x is there. So given the function is algebraic function. So given
Sir, can you speak louder?
Hello, is it okay? Is it okay?
Your voice is very low, sir.
Okay, please stand it up. Is it okay? Hello?
Yes, sir.
Okay. Now, given the function is x, if f of x equal to x on closed interval 0, 1, so every interval is consisting. Now it contains one of the element is there. This interval is consisting of the element is say x. Now, just suppose, just you have to imagine one of the real line is there. That real line of the lower value is 0 and final element that is 1. Now, in between, how can you deviate the partition points? Now, according to the interval, we must divide it into the 3 parts. 0 means 3 parts means that is the third partition points. 0 by 3. 0 by 3 means 0. Hello, some disturbance is there. Please mute is there. Hello?
Yes, sir.
That person, Sheikh Ji, please mute is there. Okay, thank you.
Sir, I am here, but I can't hear your voice.
Hello, Sheikh Ji.
It's not clear, sir.
Somebody's disturbance is there, okay? Is this okay? Okay. Given the function f of x equal to x on closed interval 0, 1 and partition point is capital P equal to set of 0, 1 by 3, 2 by 3, 1. Now in between, hello? Okay. Now given the partition set of in between the interval points, we can divide it into 3 parts, 0 by 3, 0 and 1 by 3, 2 by 3 and 3 by 3 is 1 is there. And according to the interval, we can divide it into the third part of subintervals. And according to the partition set, and it depends upon the function.
Sir, speak louder, sir. I can't hear you.
Much more speak loudly, okay? Is this okay?
No, sir, it's not okay. Your voice is very low, sir.
Please stay on the line. Hello, is this okay? Hello? Is this okay?
Yes, sir.
Okay, it's all right. Now, here the function is x. X means, given the function, means x means that is the algebraic function. This is the first degree polynomial of the function. And according to the function, the subintervals of the partitions are. How to write the subintervals? Please mute is there. Some lot of disturbance is there especially. Okay. Now, according to the partition set, we must write the subintervals. Now, first subinterval is 0 and 1 by 3. That is denoted by I1. Second subinterval is 1 by 3 and 2 by 3. That is denoted by I2. And third subinterval is 2 by 3 and 1. That is the I3. Then suppose in examination, especially partition set is not given. But how to deviate the partition set? Now, and it depends upon the function. We can divide a third. We are taking the third type of subinterval. Length is also given is there. According to the length, now third part of subintervals means we must divide it into 0 by 3, 1 by 3, 2 by 3, and 3 by 3 is also 1. Final point is given. Now, we according to the partition set, first of all, we must write the partition set, and to write the subinterval I1, I2, I3. There are 3 subintervals we have to write here. Now, every subinterval must have a one of the length. Now, length of each subinterval means, now according to the first subinterval length is 1 by 3 minus 0, that is 1 by 3. And according to the second subinterval, to write the length of the subinterval, that is 2 by 3 minus 1 by 3, that is also 1 by 3. And according to the third subinterval, we write the third subinterval length, that is del 3. So that is also 1 minus 2 by 3, that is also 1 by 3. So every subinterval, all the length of the subintervals must be equal. First of all, we must know that we have to know that now all the subintervals of the length is same. Okay, there is no change. Now, first of all, write the function. Given the function is x, f of x equal to x. That function is increasing in between 0 and 1 is there. Okay, how to write the infimum and supremum of the values? Now, infimum and supremum of the values depends upon the function. So, first of all, first subinterval of the lower value is 0. So, that value is lower value is 0. F of 0 equal to 0. So, that value is small m1. And upper value is 1 by 3. So, f of 1 by 3 equal to 1 by 3. Suppose given the function is x square is also there. Okay. F of 0 equal to 0 square. F of 1 by 3 equal to 1 by 3 whole square. But here only x is given. First degree polynomial. So, a small m1 equal to, it depends upon the lower value, and supremum value is also depends upon the upper value of the first subinterval. So, those values is substituting given in the function. So, f of 0 equal to 0, that is small m1, and f of 1 by 3 equal to 1 by 3, that is capital M1. Okay. And the supremum and infimum, again the supremum is denoted by capital M and infimum is denoted by small m. So, second subinterval of the supremum value is, what is the upper value? 2 by 3. So, f of 2 by 3 equal to 2 by 3, that is capital M2. Okay. Lower value is 1 by 3. So, that value is also substituting given the function f of 1 by 3 equal to 1 by 3. So, that is small m2. So, similarly, we must write here capital M3 equal to 1. So, because third subinterval of the upper value is 1. So, that value is substituting f of 1 equal to 1. Now, that is the capital M3. And small m3 equal to, that is the lower value is 2 by 3. F of 2 by 3 equal to 2 by 3. So, that's an f. Now, these values are denoted by capital M1, capital M2, capital M3, small m1, small m2, small m3. How to find the infimum and supremum values? Those values depends upon the subinterval of the lower and upper values. Now, according to the supremum and the infimum values, to write the upper Riemann sum, Upper Riemann sum is denoted by, now that in some time that is also denoted by upper partition of F, U of PF, or upper Riemann sum, or upper Darboux sum, whatever is. Now these are all similar names. Okay. Now upper Riemann sum is capital M1 del 1 plus capital M2 del 2 plus capital M3 del 3. Now that is a simple notion of definition is summation R equal to 1 to 3 capital MR del R. Okay, small mr is the infimum of IR. Okay, small mr is the infimum of IR. Capital MR is the supremum of IR. Now those are subintervals of the infimum and supremum to write the according to the functional values. Okay. Now first of all those values substituting. This is capital M1 1 by 3 into 1 by 3. Now capital M2 2 by 3 into 1 by 3. That is the del 2. And capital M3 1 into 1 by 3. So after the simplification we are getting the value is 2 by 3. That is the upper Riemann sum. And in the same manner, lower Riemann sum is L of PF. That is, lower Riemann sum is denoted by L of PF. In sometimes it read as the lower partition of F. Every partition, according to every partition depends upon the functional of the element. So here F be the function. That functional of the element is small x. X is also consisting one of the interval. That interval, according to the interval, to write the partition set. So lower Riemann sum is denoted by L of PF. So that value is small m1 del 1 plus small m2 del 2 plus small m3 del 3. Now that is simply notated as the summation R equal to 1 to 3 small mr and del R. Okay. What is the small m1? 0. Small m2 1 by 3. Small m3 is 2 by 3. Okay. Now those values substituting here del 1, del 2, del 3. All the length of the subintervals are same because the rth subinterval of the length is del R. First subinterval of the length is del 1 and del 2 is the second subinterval of the length. Del 3 is the third subinterval of the length. After the simplification we are getting the value is 1 by 3. So how here the especially upper Riemann sum value is 2 by 3 and the lower Riemann sum value is 1 by 3. This problem is also very important, there is no doubt. In the same manner, just you have to practice. We must practice in the above problem. Okay, find upper Riemann sum and lower Riemann sum. What is the W of PF? Students, anyone is there? What is the W of PF? W of PF or O of PF means oscillatory sum. Oscillatory sum means the difference between upper Riemann sum and lower Riemann sum. Okay. Now, if f of x equal to, this is the second problem. In the same manner, just have to see and refer the above problem is there. Now, given the function is, that is the reciprocal function. That is 1 by x, inverse of the function, 1 by x. Now, here x is consisting of the element. That element is consisting of the interval is 1 and 2. This is the closed interval. Closed means both sides square bracket is closed. Okay. Now, somebody is there? Okay, solve. Okay, that is the reciprocal function. How to write the in between 1 to 2? How to write the partition set? According to the reciprocal, how to get in the value in between 1 and 2? How to write the partition set? Now, the difference between you are taking the value is just you have to imagine here. Okay, what is the value? 1 by 2 is there. Suppose x equal to 2. X equal to 2. 1 by 2 is 0.5. 0.5, that is the 1 by 2 equals to, that is the 0.5. In between, we are taking the difference 1. 1 plus 0.2, that is 1.2. And 1.2 and 1.4. Okay, so length of the interval is just 0.2 is there. Length of the interval is 0.2. According to the length of the interval, just you have to construct the partition set of the, according to the partition set, we must write the subinterval. So 1 1 plus 0.2, that is 1.2. This is the first subinterval. And again, second subinterval is continuation of second subinterval is according to the first subinterval 1.2 and 1.4. In between the difference is 0.2. That is the length of the subinterval. Okay. Second subinterval is I2. Length of the subinterval is del 2. I3 and 1.4 plus 0.2. That is 1.6. That is the subinterval. Third subinterval. Fourth subinterval is 1.6 and 1.8. That is the fourth subinterval. And the last subinterval, fifth one is 1.8 plus 0.2. Now we are getting the value is 2.0. That is 2. So now final point is also given is there. So in between 1 and 2, we are taking the difference between those partition points. Just that is the 0.2. That is the length of each subinterval. Del 1, del 2, del 3, del 4, del 5. Every subinterval of the length is denoted by del. First subinterval is del 1. Second subinterval of the length is del 2. And mod I3 means del 3. Mod I4 means the length of the subinterval L of I4. That is also del 4. L of I5, that is mod I5 equal to 0.2. So here the length of the subinterval is here. Clearly, just given the function is the reciprocal function 1 by x. That function is also reciprocal function means 1 by x. Now that is decreasing on close interval 1 and 2 because given the function is the reciprocal, that is the inverse function. So that's why given the function is a decreasing. Okay. Now here, according to the first subinterval of the supremum, capital M1. What is the capital M1? Here the lower value is 1, upper value is 1.2. Those values substituting given this function. 1 by 1 is 1. 1 by 1 is 1. That is small m1. So this is the reciprocal function. 1 by 1.2. Okay. 1 by 1.4. 1 by 1.6. 1 by 1.8. So this is 1 by 1.2. 1 by 1.4. 1 by 1.6. 1 by 1.8. Now these values denoted by, that is here small m1 value in the same manner. Okay. So u of pf equal to upper Riemann value is all the length of the subintervals is 0.2. So m1, first capital M1 is 1. Capital M2 is 1 by 1.2. 1 by 1.2 can also be written as this is 1 by, what is that? 1 by 10. Okay. So that is 10 by 2 is there. Now this can also be written as 10 by 2 because the reciprocal function, in the reciprocal function, those values substituting in the function, now that is the, all the lower values are supremum values and all the according to the upper values are, we are converting into the reciprocal function, that is the infimum values. So that's why upper Riemann sum equals to all those values substituting. Capital M1 is 1, capital M2 is, what is that? Capital M2 is 1 by 1.2 and capital M3 is 1 by 1.4 and capital M4 is 1 by 1.6. Capital M5 equal to 1 by 1.8. Now these values are converting into this side. So this is 2 by 10. 2 by 10 means 1 by 5. Okay. 2 by 10 is also in the reverse of the part 10 by 2. This is 4 by 10. That is 10 by 14. Okay. Next, this is 16 by 10 by 16. This is 10 by 18. Okay. So all the those values, capital M1 del 1, capital M2 del 2, capital M3 del 3, capital M4 del 4, capital M5 del 5. So after the simplification, we are getting the value 0.75. In the same manner, lower Riemann sum, all the length of the subinterval is same, that is 0.2. In the same manner, small m1 is that is 2 by 10 by 2. That is 12 by 10 and 14 by 10. So 10 by 14 and 10 by 16, 10 by 18 and the same manner 10 by 20. So after the simplification, we are getting the value is lower Riemann sum. Okay. Now students, this is also very important theorem. There is no doubt because just have to see and refer this theorem. See in the last class and continuing in your textbook properties of Riemann integrals. Just you have to see and refer just one more to repeat here. Now that term is these two terms are very important, especially in the final examination. That term is state and prove a necessary and a sufficient condition for Riemann integrability. Already the last session, just see carefully, listen carefully. Already I have explained in through the textbook. Now this theorem is necessary and sufficient condition for Riemann integrability. Hello, somebody is here? Yes, sir.
Yes, sir.
Okay, your volume is clear.
Sir, I didn't understand what you taught because the volume is very low, sir. I told you, but you didn't correct it.
Actually, the high volume is here, madam. Okay, is it okay?
Sir, how can we understand when we didn't get the volume?
Hello, is it clear? Is this clear?
Yes, sir.
Okay. Now, this term is state and prove a necessary and sufficient condition for integrability. This bit is there. Okay. Now, this theorem is what is the statement of Riemann integrability condition? Now, already I have explained in the last session what is the given the function is Riemann integrable. F belongs to R of AB. F belongs to R of AB means F is Riemann integrable on closed interval AB. Now that is when the lower Riemann integral means lower limit a to b f of x dx, upper Riemann integral means upper limit a to b bar. Upper limit a to b f of x dx equal to integral a to b f of x dx. When the lower Riemann and the upper Riemann integral must be equal, so that's why given the function is integrable. That is Riemann integrable, integral a to b f of x dx. Simply is denoted by f belongs to R of AB. That's why it read as f is Riemann integrable on closed interval AB. This is the necessary part. So first of all, write the statement. Necessary and sufficient condition of integrability means Riemann integrability in necessary and sufficient condition. This theorem very important in the final examination. Without this theorem, you can't expect the question paper. Okay. Now here the statement is a bounded function. What is the bounded function? Here f be any bounded function. Function must be bounded means that interval is on the real line must be closed part. So R be the real line. This is the real line. Interval points is initial point is A and terminal point is B. So that's why here the function is f from interval AB to capital R. So here the function is defined from interval AB to capital R is Riemann integrable on closed interval AB. That is the necessary part. If and only if means necessary and sufficient condition. IFF means necessary and sufficient condition. For each epsilon greater than 0, there exists a partition of P of closed interval AB such that when the epsilon be any number, that number must be greater than 0. Here the existence is consisting of the interval of the partition set is capital P such that now upper Riemann sum and lower Riemann sum, the difference between the upper and the lower Riemann sum, that is called oscillatory sum. So instead of this one, W of Pf or O of Pf lies between 0 and epsilon, because oscillatory sum is greater than or equal to 0, but it is less than epsilon, because epsilon is always greater than 0. Here epsilon be any number. That number instead of the function is denoted by the vertical axis on the vertical axis. Now del is also greater than 0. Del be any number. That is also one of the neighborhood on horizontal axis. Okay. Now here that is the geometrical interpretation. First of all, to write the necessary part. Already in the last session is also explained in this theorem. Now it is briefly explained here through the notes. Here necessary part is, first of all, you are taking the given the function is Riemann integrable. To write the Riemann integral condition. What is the Riemann integrable condition? Lower Riemann integral equal to upper Riemann integral equal to integrable function. Integrable function is integrable a to b f of x dx. Say this is the first equation. Now, here epsilon be any number, that number must be greater than 0. Already we have explained Darboux theorem. What is the Darboux theorem statement? In the existence of the part, here del be any number, that number must be greater than 0 such that upper Riemann sum less than upper Riemann integral plus epsilon by 2. Say this is the second equation. In the same manner, lower Riemann sum and lower Riemann integral, comparison between those, lower Riemann sum is greater than lower Riemann integral plus epsilon by 2. This is the third equation. Now, this is the partition set denoted by pi of closed interval AB. So, according to the partition set, we are taking only one partition is capital P. P being any one of the partition from the partition set. Norm P is less than del Z. Now comparing it between first and second equation, from first and second equation to now substituting in the upper Riemann integral equal to Riemann integral. That is integral a to b f of x dx. So that's why upper Riemann sum less than integral a to b f of x dx plus epsilon by 2. So upper Riemann sum now that is less than. What is the value of this one? From first and third equation, the same manner 1 and 3. What is that? Lower Riemann sum is greater than lower Riemann integral replacing from the second equation. That is the Riemann integrable function plus epsilon by 2. So that value is also Riemann integrable of the value L of PF plus epsilon by 2. Epsilon by 2 plus epsilon by 2. So that value is epsilon. So upper Riemann sum minus lower Riemann sum is less than epsilon. That is the simple concept. So oscillatory sum is less than epsilon, but it is also from the condition, given the condition, it is greater than or equal to 0. So that's why necessary part is also derived. But in the same manner, sufficient part is, we are taking first of all from the partition set, pi of closed interval AB is the one of the partition set. In the partition set, we are taking one of the partition. So that partition is PB any one of the partition. Here especially there exists epsilon b greater than 0. Partition set is capital P of closed interval AB such that 0 less than or equal to upper Riemann sum and minus lower Riemann sum less than epsilon. First of all, we are taking the given this condition. Okay, please stay on the line. Please stay on the line. Please stand there. Okay. Now, especially now, just you have to see and refer this one sufficient part. This is the second part of the theorem. Now, especially in the analysis, every theorem must be explained here through the necessary and sufficient part is there. Okay. Now, sufficient part is here. First of all, we are taking the oscillatory sum lies between 0 and epsilon. What is the oscillatory sum? Now, the difference between upper Riemann sum and lower Riemann sum. So, by definition, upper Riemann, what is the definition of upper Riemann integral? Upper limit a to b f of x dx equal to when the upper Riemann sum of the infimum value is called upper Riemann integral. Okay, what is the result of this is the definition of upper Riemann integral. Upper limit a to b f of x dx. So some students are also late joined here, especially because there is no problem from the beginning of this part. Very useful, especially important. This through the online. Okay, through online. Okay, there is no problem. Now, in the next section is also just you have to please sharp at you. We must attend the sharp at 1:30. 1:30 plus. Okay, don't delay here. Now, by definition of upper Riemann integral, upper limit a to b f of x dx equal to infimum of upper Riemann sum. Here PB any one of the partition set. From the partition set, we are taking the partition P is there, and according to the partition, then you have to write the upper Riemann sum, and upper Riemann sum of the infimum value is called upper Riemann integral. So comparison between upper Riemann integral and upper Riemann sum. So upper Riemann integral is always less than or equal to upper Riemann sum. So this is also one of the equation, first equation in the sufficient part. And in the same manner, similarly, by definition, lower Riemann integral equals to supremum of L of Pf. Supremum of L of Pf. When the lower Riemann sum of the supremum value is called lower Riemann integral. Okay. Now, here from the partition set, we are taking PB any one of the partition. So, what is the lower Riemann integral is always greater than or equal to lower Riemann sum. Lower Riemann integral is always greater than or equal to lower Riemann sum. Now, in the conversion, the negation is also applied here. The negation of lower Riemann integral less than or equal to, because negation of greater than or equal to, that is the negative of greater than or equal to, that is less than or equal to. So, the negative of lower Riemann sum. Okay, the students listen carefully, especially in the examination. Already we have explained from the beginning of in the session, from the beginning of Riemann integral, u of p comma minus f. From the negative on the negative function, upper Riemann sum value is equal to the negative of lower Riemann sum. Please note down u of p comma minus f. U of p comma minus f equal to minus L of Pf. Minus L of Pf. Okay. So it read as on the negative function upper Riemann sum equal to the negative of lower Riemann sum. In the same manner, L of p comma minus f equal to means on the negative function lower Riemann sum equal to the negative of upper Riemann sum minus of u of Pf. Now these two are very important in the same multiple choice questions. Okay, so don't misunderstand here. Yeah, now this is one of the most important. This is very useful from the partition set of the properties. Okay, now the negative of in the same manner from the definition of lower Riemann integral equal to supremum of L of Pf, and here lower Riemann integral is always greater than or equal to lower Riemann sum. So in between lower Riemann sum and the lower Riemann integral of the conversion is, that is the order condition is lower Riemann integral is greater than or equal to lower Riemann sum. Okay, and at the same time we must apply here the negation in between the lower Riemann integral and the lower Riemann sum. Okay, do you understand here? The negative of lower Riemann integral is less than or equal to the negative of lower Riemann sum. From the first and second equation, so when the upper Riemann integral minus lower Riemann integral is less than or equal to upper Riemann sum minus lower Riemann sum. Already we know that in the from the beginning of sufficient condition, so that value is oscillatory sum value is less than epsilon. So that's why this value less than epsilon is greater than or equal to 0. Just have to see here. This value is less than epsilon is greater than or equal to 0. So that's why upper Riemann integral minus lower Riemann integral is greater than or equal to 0. That's why upper Riemann integral equal to lower Riemann integral. When the LRI means the lower Riemann integral and URI means the upper Riemann integral. When the both values are must be equal, given the function is Riemann integrable. That is f belongs to R of AB. So that is simply read as f is Riemann integral on closed interval AB. That is f belongs to Kepler of AB. That is denoted by integral A to B f of x. Okay, that's enough, students. This is also one of the finest theorem and one of the important theorem, especially in the Riemann integrals. Okay, don't mislead here. Now, according to the above theorem, just you have to practice one of the important problem here. What is the problem? From the on the Riemann integral, for Riemann integral of the problem is given the function is f of x equal to 3x plus 1. Now, this is the simple function. This is the now this function is instead of ax plus b or a plus bx, whatever it is. This is the first degree polynomial function, or simply this is the simple straight line ax plus b. Okay. Now given the function is 3x plus 1 or 8x plus 1, whatever it is, there is no problem. So this is the algebraic function is integrable on interval points is 1 and 2. First of all, how to deviate the partition set? How to deviate the partition set? Now, especially just you have to see and refer here. One more student is also added. Okay, number of times attendance we are taking here. Please stay on the line. Please stay on the line. Late joining or late comers are also joined here. Okay. No problem. Just for the attendance purpose. Okay. Next one. See the students. Now, given the function is 3x plus 1. This is the comparison between. Given the function is this is the first degree polynomial of the function, or simply that is a plus bx or a plus bx. So according to the straight line, given the straight line is integrable on closed interval 1 and 2. So according to the interval, how can you deviate the partition points? Now this is one of the important concept here. Okay, how to deviate the partition points? Just you have to see and hear. Now we must prove that integral 1 and 2 f of x means given the function is 3x plus 1 of dx. This is the simple integration. Integral 3x dx plus integral 1 dx. That is 3 into integral x dx means x square by 2, and interval points is 1 and 2. That is the lower limit is 1, upper limit is 2. Plus integral 1 dx means x, applying the interval upper limit minus lower limit. Okay, we are getting the value is 11 by 2. That is the simple integration, but it is not sufficient, because through the Riemann integrals concept, how to find the value integral 1 to 3 f of x dx equal to 11 by 2. So first of all, that is the given the part. First of all, we must write f of x equal to 3x plus 1. Is this function bounded or not? Yes, this function is bounded in between 1 and 2. Okay. First of all, consider the partition set. What is the partition set? Capital P equal to set of. So, hello? Okay. Partition set capital P equal to set of 1 comma. What is the rth subinterval? Rth subinterval means according to the 1 and 2, lower value is 1 plus r minus 1 by n, comma 1 plus r by n. This is the rth subinterval. Okay, first of all, lower value is 1, and adding with the value is 1 by n, 1 plus 1 by n, comma 1 plus 2 by n, comma so on, 1 plus r minus 1 by n, and at the same time 1 plus r by n. Now 1 plus r minus 1 by n and 1 plus r by n, this is the rth subinterval. Every partition set must be represented as the rth subinterval. IR equal to, that is rth subinterval is denoted by 1 plus r minus 1 by n and 1 plus r by n. So every length of the subinterval, suppose to write the length of the subinterval means the upper value minus lower value, 1 plus r by n minus 1 minus r minus 1 by n. After the simplification, we are getting the rth subinterval length, means length of the rth subinterval is denoted by mod IR equal to L of IR. This is also simple multiple choice question. What is the rth subinterval of the length? Del R equal to, that is denoted by del R. Okay. Now, rth subinterval is denoted by every subinterval in between the A and B, or XR minus 1 and XR. That is the rth subinterval. So XR minus 1 value is here R minus 1 by n. XR value is R by n. Now both values are adding with the lower value. So that is the rth subinterval in between 1 and 2. That is 1 plus R minus 1 by n and 1 plus R by n. So all the length of the subintervals are same. So especially given the rth subinterval of the length is denoted by del R. That value is 1 by n. So this is the first subinterval 1 comma 1 plus 1 by n. This is the second subinterval 1 plus 1 by n and 1 plus 2 by n. Okay. In the same manner, rth subinterval is 1 plus r minus 1 by n and 1 plus r by n. This is the rth subinterval. Length is second value minus first value. on the subinterval. So we are getting the value, all the length of the subintervals are equal. So that's why that is denoted by del R, that value is 1 by n. So first of all, to write the function f of x equal to 3x plus 1, this function is increasing on closed interval 1 and 2. Write the supremum of, that is the supremum is denoted by capital M, infimum is small m. Write the infimum and supremum values through the function. So supremum value is here, R subinterval of the upper value is 1 plus R by n. So this value is substituting given this function 3 into 1 plus R by n plus 1. We are getting the value, this is 3 plus 1 is 4 plus 3 R by n. And in the same manner, here the R subinterval of the supremum is capital M R. We are getting the value 4 plus 3 R by n through the R subinterval of the upper value. So upper Riemann sum equal to U of Pf equal to summation capital M R and del R. Summation capital M R value is 4 plus 3 R by n and del R value is 1 by n. So after the simplification, 4 into 1 by n plus 3 into R by n square. Okay. Now here especially summation 4 by n, 4 is the constant. Now that value is that is the numeric value. Now we are taking outside at 4 into summation 1 by n is there. Okay. In the same manner, 3 is also taking outside summation. That is the value is 3 into what is the value? 3 for 3 R by n square. Okay. Now here R by n square is also 3 by n square is also taking outside. We are getting the value summation R. Okay. Now that is a simple value. Summation of the value is that value is n. 1 to n values, 1 plus 2 plus 1 up to n values means that overall the value is n is there. Okay. 4 by n is constant. Summation of 1 means sum of the natural numbers is denoted by n. So summation R. Summation R means sum of the natural numbers. Up to 1 to here, R varies from 1 to n. What is the formula of, already we know that here in the progressions and series is also there. Sum of the natural numbers is denoted by n into n plus 1 by 2 because upper value is n. Summation R means R varies from 1 to n. Means that value is n into n plus 1 by 2. 3 by n square is constant. So both n values are cancelled. This is 4 plus 3 by n square of n into n plus 1 by 2. After the simplification, that value is 3 by 2 into, now n value is also cancelled here. N in n square is n times. So n by n means 1 plus 1 by n. Okay. In the same manner, lower Riemann sum. Already lower value is in the R subinterval 3 of 4 plus 3 of R minus 1 by n. That is the lower value. That value substituting given this function, we are getting the value is the small mr. Okay. Small mr is also 4 plus 3 of R minus 1 by n. Del R value is 1 by n. After the simplification, this is 4 into summation 1 by n. So 4 by n is also taking outside. Summation 1 is there. And 3 by n square is also constant. Summation R minus 1. Summation R minus 1 means that is the simply, this is also sum of the natural numbers because R varies from 1 to n. So the voice is not audible, sir. Number of times. Okay, I can't. Hello? Is it clear, students? Is this clear? Okay. Now this is summation 3 by n square. Now already we know that in the progressions. Okay, thank you. Now this is 3 by n square. This is the constant. Okay. Here, what is the replacing of the sum of the natural numbers is n into n plus 1 by 2. The replacing n by R minus 1. We are taking the value is n minus 1. Okay, n of n plus 1 by 2. Replacing n by R minus 1. And R minus 1 plus 1 means R is n is there. So by 2 is there. So finally, here n into n square is also there. So n square is cancelled, and n by n square means by n is there. So this is 1 minus 1 by n. 3 by 2 is constant. So we are getting the values 4 plus 3 by 2 of 1 minus 1 by n. So according to this one, first of all, we have to find the upper Riemann integrable. When the lower Riemann sum of the limit point is called lower Riemann integral. This is lower limit 1 to 2. This is 1 underscore. Please note down 1 under bar is here. This is lower limit 1 to 2 f of x dx equal to limit L of P and F. When the simply lower Riemann sum, the definition is limit point of lower Riemann sum is called lower Riemann integral. Limit n tends to infinity, lower Riemann sum value is 4 plus 3 by 2 of 1 minus 1 by n. Already, students, please listen carefully. Limit 1 by n. When n approaches to infinity, that value is always 0. Please note down. Limit n tends to infinity, 1 by n is does not exist because that value is 0. Okay. So limit n tends to infinity, 1 by n. Because n approaches to infinite. Infinite means 1 by 0. So then automatically limit 1 by n equal to 0, limit 1 by n square equal to 0, here n being a natural number. In the same manner, we are getting the values, this value is 0. When the applying of the limit point, here n approaches to infinity, we are getting the values 4 plus 3 by 2. 4 plus 3 by 2 means 11 by 2. Okay, so in the same manner, upper Riemann integral equal to upper limit 1 to 2 bar. Upper Riemann integral means 2 bar. Integral 1 to 2 f of x dx. That is the simple definition. Limit the upper Riemann sum. Upper Riemann sum value is already we know that 4 plus 3 by 2 of 1 plus 1 by n. Okay. So we are getting the limit 1 by n equal to 0. We are the simple value 4 plus 3 by 2. We are getting the value is 11 by 2. So when the lower Riemann integral and the upper Riemann integral, both values are equal. So given the function is Riemann integrable. So that's why it is denoted by integral 1 to 2 3x plus 1 of dx equals to 11 by 2. Students, now this is one of the finest problem and one of the important problem in the final examination through the Riemann integration. Okay. Now there are so many problems are here. F of x equal to sin x is increasing, and given the function is integrable on closed interval is a and b, or 0 and 1, whatever it is. So integral sin x dx means simply that is minus cos x. When the limits are 0 to a, okay, minus cos a, minus of minus plus cos 0. So minus cos a plus 1. Now, these problems are also practiced. Just see and refer in your textbook. There are so many problems through the Riemann integration. Students, listen carefully. Now, in the last, especially in this session, one of the finest important theorem, state and prove fundamental theorem of integral calculus. This theorem is also very, very important, especially in the real analysis. And it is consisting especially that is the consisting of Riemann integration. Okay, this theorem is much more useful in the Riemann integration. Without this theorem, that is also can't expect the question paper in the final part. Okay, now that theorem is fundamental theorem of integral calculus. Please stay on the line. Please stay on the line. Students, all are okay?
Yes, sir.
Sir,
Hmm.
sir, can you give some important questions for exam?
These are all very most important, especially. Already I explained much more important the final examination. Okay. In the last class, especially last class is also there. Already 3 classes is gone. Remaining 3 classes and especially 5th class through the online, I must given some important problems in the final session. Okay.
Yes, sir.
Okay. Now this theorem is also very important in the final examination. There is no doubt. Now recently I explained Riemann integrability condition, and this is the theorem is the fundamental theorem of integral calculus. Should listen carefully. Now, what is the statement of fundamental theorem of integral calculus? So, given the function is Riemann integrable, f belongs to R of interval AB. Now, f is Riemann integrable on closed interval AB. And what is the pi? Pi means that is the primitive of the function. Pi is the primitive of the function is there. Then, given when the function is Riemann integrable, that is the Riemann integrable is denoted by f belongs to R of AB. And pi is the primitive of the function. Then integral a to b f of x dx equal to pi of b minus pi of a. What is the pi? Pi is the primitive. Primitive means the antiderivative. Okay. Now here the function is pi is the primitive function that is denoted by primitive function means that is the antiderivative means pi dash of x equal to f of x. This is the meaning of given the statement is pi dash of x equal to f of x. Here x is consisting of the element. That element is consisting of the interval is closed interval AB. Okay, well, that is the simple statement. Fundamental theorem of integral calculus. Fundamental theorem of integral calculus is if f belongs to f is Riemann when the function is Riemann integrable on closed interval AB, pi is the primitive of the function. Then integral a to b f of x dx equal to pi of b minus pi of a. That is the statement of fundamental theorem of integral calculus. Simple proof is here pi is the primitive of the function. Okay, primitive function is denoted by pi dash of x equal to f of x for all x belongs to closed interval AB. That is the first equation. We know that Riemann integrable function, that is the simple definition, integral a to b f of x dx equal to, that is limit non-p tends to 0. Here p being any one of the partition, so that must be erased here. P belongs to pi of closed interval AB. Okay. Now, according to the partition set, to write the one of the partition of the norm, limit norm p tends to 0, summation f of zeta r. Now that is zeta r, f of zeta r and del r. This is also one of the element. So instead of x is there. Okay, f of zeta r del r. That is the definition of Riemann integrable function. Simply integral a to b f of x dx, that is the Riemann integrable function through the limit partition of the norm, limit norm p tends to 0, summation f of zeta r and del r. Del r means of subinterval of the length. Okay, zeta r is consisting of the length of the subinterval, that is closed interval xr minus 1 and xr. So when the function is pi is derivable on closed interval AB. Okay, when the function is given the function primitive function, when the pi is derivable on closed interval AB, already we know that one of the important property, every derivable function is continuous. The function is derivable when it is there, then it is continuous, but continuous function is not derivable. Now I can't understand, especially in this material, without continuous and derivable part, how can you explain the integrable function? How to calculate the function? Okay, first of all, you must know that what is the function which is continuous. What is the continuous condition? Now, through the original access, we are taking the given the function of the element is x is there. X is consisting interval points. Through the interval points, the element is defined at x equal to c. Now, from the origin is defined from mod x minus c less than del is there. Mod x minus c less than del means x lies between c minus del and c plus del. That is the neighborhood of the point. Without neighborhood, without continuity definition, without a derivable condition, how can you given especially this content? How can you introduce in this material? Okay, especially first of all, we must know that what is the function of the continuous and what is the function of derivable condition. Okay, how to define that one? Now, continuous condition is now that is the origin is defined from the origin. 0 from mod x minus c less than del for all x belongs to interval of AB. Given the function is defined, given the orbital of the element, interval element x is defined at x equal to c. Because mod x minus c less than del means now here the neighborhood of the point is c minus del and c plus del. Here del is always greater than 0 on the horizontal region. Same horizontal region, those points is substituting given to the function f of x is consisting f of c minus epsilon and f of c plus epsilon. F of c minus epsilon and f of c plus epsilon. So that is the functional concept. When the mod f of x minus f of c less than epsilon, that is the continuity condition. Okay, so that's why I must explain the continuity condition is there. When the function is continuous and derivable on the R subinterval, xr minus 1 and xr. Put r equal to 1 to r varies from 1 to n. Put r equal to 1. 1 minus 1 is 0. So x0, x1 is the first subinterval. That is I1. I2 equals to r equal to 2. That is x1 and x2. And r equal to 3. That is x2 and x3. Now to write the r subintervals of the nature. Okay. Now especially when the function is continuous, when it is derivable. What is the derivable condition? Already we know that in the latter, just we have to practice in the first level. First semester is also there. Okay, how to find the derivative? How to find the derivable functions? What is the first principle of the derivative? Now f dash of x equal to limit x tends to c, f of x minus f of c by x minus c. Or first principle of the derivative through the height of the interval limit h tends to 0, f of x plus h minus f of x by h. That is the first principle of the derivative. In the same manner, in the geometrical expression, limit delta x tends to 0, f of x plus delta x minus f of x by delta x. Delta x is always tends to 0, approaches to 0. That is the first principle of the derivative. According to the derivable functions, now how to explain the mean value theorems? Rollet theorem already just you have to practice, you have to learn the first semester of this part, derivable functions. Rollet theorem, Lagrange mean value theorem, Cauchy mean value theorem. Some theorems are also you have to practice on the derivable functions. Okay. By Lagrange mean value theorem, what is the Lagrange mean value theorem? If f maps interval AB to R is a function such that f is continuous on closed interval AB and function is derivable on every continuous function must be explained on closed interval AB because continuous function is bounded on closed interval AB. But in sometimes bounded function is not continuous. That converse is not possible in sometimes. Okay, converse of the theorem need not be true, especially. Now, in sometimes at the same time, given the function is derivable function is always depends upon the open interval of this part on open interval AB. Okay. Now, derivable function, according to the derivable function, when the both function values are equal, f of a equal to f of b, and pi dash of x equal to what is that? Hello, students. Now pi dash of x equal to the f of b minus f of a by b minus a. What is the Lagrange mean value theorem? Then the f dash of c equal to f of b minus f of a by b minus a. To write the replacing of the function f by pi function is there. Pi of xr minus pi of xr minus 1. Because according to the R subinterval points, b value is xr, a value is xr minus 1. Okay, some students are jumped here. There is no problem. I am not the problem is here because now this is the very important session. Without classes, we can't listen to without classes. How can you write? Okay. Now this is very simple concept is there. Now this is pi of xr minus 1 equal to now pi dash of zeta r. This is the mean point. Pi dash of zeta r equal to pi of b minus pi of a by b minus a. So interval point R subinterval xr minus 1 and xr A value is XR minus 1 and B value is XR there. So pi dash of C value is, that is the mean point. Mean value is zeta R. Pi dash of zeta R equal to pi of B minus pi of A by B minus A. Now, here the mean value is represented in between odd subinterval of the points XR minus 1 and XR. We are applying on both sides summation of the value. Summation R equal to 1 to N in the Lagrange mean value theorem's concept. Okay. Summation R equal to 1 to N on both sides in the Lagrange mean value theorem representation. That is summation R equal to 1 to N pi dash of zeta R and R. Now, XR minus 1 that is denoted by del R. So, already we know that pi dash of X equal to F of X. Here X equal to zeta R. So, that's why pi dash of X equal to, we are taking and we are replacing the value from the first equation. That is F of X. X means the zeta R. Okay. Finally, we are we have to replacing the R varies from 1 to N. Put R equal to 1, pi of X1 minus pi of 1 minus 1 is X0. R equal to 2, pi of X2 minus pi of X1. In the same manner, pi of Xn minus pi of Xn minus 1. Okay. After the simplification, just we are only just that after the simplification we are getting the result is pi of Xn minus pi of X0. Remaining all the values are cancelled. Pi of minus pi of X1 plus pi of X1 minus pi of X2 plus pi of X2 and minus pi of Xn minus 1 and before that plus pi of Xn minus 1. We are giving the value just after the cancellation of the values. We are giving the values is pi of Xn minus pi of X0 equal to summation F of zeta R and del R. And now at the same time we are applying on both sides limit nature is there. When the limit non-p tends to 0, pi of Xn minus pi of X0 equal to limit non-p tends to 0 summation F of zeta R and del R. So already we know that, and Riemann integrable definition here replacing the Riemann integral a to b f of x dx. Put the xn equal to b and x, when the final point is xn equal to b equal. When the b is equal to xn and a equals to the initial value is x0 is there. So pi of b minus pi of a equal to integral a to b f of x dx. That is the simple theorem. This theorem is very important in the final examination. Now the theorem is the fundamental theorem of integral calculus. Students, last but not least here, once I have to repeat here, now that is the simple statement of fundamental theorem of integral calculus is, when the function is Riemann integrable on closed interval ab and the pi is a primitive of f, then integral a to b f of x dx equal to pi of b minus pi of a. Now this is the end of the session. Now this theorem is very important and very useful in the final examination. Today's class very important. Listen carefully. Just you have to practice. Already all the notes are posted through the WhatsApp. Okay, just see and refer the WhatsApp. Now these theorems are simple representation through the notes. Okay, in your textbook just a little bit confused here. There is no problem. There's some text in your textbook. All the proofs are same, but the simple notion is here. That is our representation. Now through the notes, very simple representation. Just like that, this is one of the important theorem, fundamental theorem of integral calculus, and a necessary sufficient condition of integrability, and the function is continuous. That is the properties of a continuous function. Now, on the next class, I explained here for properties of Riemann integrals, and thereafter that is the completion of Riemann integrals concept. Okay. Now we will explain in the next class the properties of Riemann integrals. Okay. Now, thank you one and all students. Anybody is here? Any doubts?
Yes, sir.
Okay. Now WhatsApp group is there. Please note this number. Our number is 9989. Please note this number 9989 476833. This is my number, and just I have created one of the group is there. Use the
number
hello.
number mala cheppandi sir.
So just you have to see here. Please see on the screen.
Sir, I am not in that group.
Oh, okay, no problem. Please see on my number. Please see on the scale. Please see
Yes, sir.
on the screen. 9989476833.
Double
This
nine
is
eight
my
nine
476833.
4768. Okay,
Okay.
thank you.
Okay, most welcome. This is my number and students listen carefully. My name is Srinivas Rao. There is a faculty of mathematics. There is no doubt this is especially used in third semester mathematics. Now, if you have any doubt through the WhatsApp, just have to contact us through the WhatsApp. All the doubts are clear through the WhatsApp. Okay, don't misunderstand me. All the doubts are clarified here. Okay, thank you one and all. Just some of these PDF are also posted. Once I have to post it here, there is no problem. Okay. Now wish you all the best and wish you good luck.
Okay. Thank you.
Most welcome.
Thank you, sir.
Most welcome. Most welcome. Thank you one and all.
Thank you, sir.
Most welcome.